Okay, well, we're doing something again today. Okay. Music doesn't have to be very loud, but we're gonna start with we're gonna skip all those all the basics. I'm assuming we should do that. Actually, we should just we should just do that just for the sake of doing that because what's the point of not doing that? I think what I'm going to do is let's utilize some space. There we go. All right, and we might not need that if we have this in terminal. So whenever we need to call that, I can just bring that forward. Okay. Okay. All right. So where were we yesterday? I think yesterday we finished and we got all the way to functions. So how about we start with functions, and we're gonna start with the same file, right? We're not gonna open a new file because it's just gonna be too much for us to do that. Let's create a new function main, a new main, and what do we have? Okay, and then we function another function. And we pass no parameters, we just a print line. That's all this function is going to do. Okay, I guess it's just to show us that it's possible. I mean, it would make sense. I mean, that's the whole point. Anyway, we're just following orders. Um, okay, and then another function. We're just gonna call that. There is no parameters we're supposed to be passing, and that's what we got. We got hello world and another function. That's the strings we got. Okay. Um, if you want to read the whole thing, you're gonna have to do that yourself. It's just yeah. Anyway, okay. Now we're gonna add parameters. All right. So instead of just saying, instead of just saying another function, we're gonna give it a parameter, and the first parameter, or the only parameter, would be an i32. Okay. So whenever we call another function, we need to give him an i32. Okay, and now when we, sorry, before we do that, they say the value of x. Okay, of x is x. Okay, so now when we print that, right, when we run that, we get hello world, and the value of x is 5, right? So far, that is pretty simple, right? Okay, let's continue. Try running this program, and okay, we got the value. Right, now we're going to pass a second parameter, and we're going to pass the unit label. Unit label, and that is going to be a char. Now, if the type is not correct, obviously it will not run. If we do h, it will have an issue because this is a string slice and this is not a char. Okay. There you go. All right. Now we need to pass that thing. I'm not. Let's just copy the thing. How about that? Oh, they changed it to value. All right, so that it's value. Value. Okay, so now if we run this, we should get the measurement is 5h, 5 hours. Okay. We can go insane if we want to change that. I mean, this would work with I think most of the format languages. Like can make it a new line if we were not happy with that. So it does the 5 and then the h. We can do another. Just it doesn't matter. It's not going. It's just formatting, right? Just for readability. Okay. We're continuing. It creates a function named. That's not the name of the function we gave, but sure, that works. Let's look at some examples for what? Statements and expressions. Okay. Alright, so when we Alright, we're gonna declare a statement. Alright, so let, I guess, y equals 6. Y is a 6. That's a single argument or a single statement. Yeah. Function definition or so statements. Statements do not return values, therefore you can't assign a let statement to another variable as the following code tries to do. We cannot let a statement within a statement. Does that, I guess that makes sense. Therefore, you cannot assign a let statement to another variable. So he's using here a let statement as the variable, and that is the problem. Can I keep that? Can I keep this one on top? Can I do that? No, I cannot do that. Maybe I can, but I don't know how. Anyway, maybe there's a way of doing that. Okay, let's continue with this. Okay, we understand the statements. You cannot put a statement as a as the variable of the statement, so that makes sense. What else do we have? It's not return value, right? It's just a statement. It's not a function. We're not saying, hey, take this, do this. We're just saying this equals to this. Ignore the let and ignore the I32. You just we're just saying y is 6. That's all we're saying, and rest of it is formatting for the compiler. So we get that, we understand that. Function main, okay, what we're doing here. Expressions evaluate a value and make up most of the rest of the code. Okay. All right, so now that's an expression. So we say, how about we get rid of this because we're doing something new. And we're gonna make a new main. Okay. So we're gonna start with a statement, and the statement is y is equal to 6, right? Y is 6. But now we're saying, okay, let's make it more advanced than that. Right now we're not returning anything. If we want to return something, we need to create a return, and the format for this one is just that's not what I meant to do. The val is y. Okay. Now he's happy within his clause. No, that's not how they call that. They called it clause, or they called it what do you call them? Rust clause? Clause? Crabs clause? Yes, it's clause. Is there another word for that? Has to be another word for that. Arms. YouTube, don't be angry with me. There you go. What? Anyway, clause. Are we gonna call that clause? Cause that's the name. Oh, that's stupid. Anyway, all right. So now we'll get an output, right? Because we have the output, and now we say instead of just a single expression of instead of a single expression of y is equal to y, let's make this a bit more advanced, and we're gonna create a block. I think we have to close a block. I'm pretty sure we have to close a block. And now we can let now we can well, I guess let's make it. So this is a statement. Right, you see, this is why I'm doing this, because I thought I was the smartest, but now I know I'm not. Also, now I know the right names, because when you read it, you don't have the connection. Well, I understand better when I read it than when I listen to it. So all the courses I took, I got them right because I'm good with doing that because it's logic, but with the actual code I didn't understand. So this is why we're doing this. All right. So now we're creating. So this is a statement. Well, both of them will be expressions of the same statement of the of the y statement. So this is an expression of y, and now we're going to create an expression of x. So if x is 3, we're going to say x plus 1, and now we should get 4, like y should be 4 because we're returning a single I32. It still is the same as what we expected before. Alright, so we get 4. Okay, so far we're happy. Right, expression evaluates a value and make up the most of the rest of the code that you'll write in Rust. Consider a math operation such as, which is an expression that evaluates to the value. Okay, so the expression is part of the statements. Yeah, that I understood correctly. Yep, this is the expression and this is the statement. It is a statement, but because it is a value of that key, I guess. Is that a key? That variable? Function with return values. Okay, this should be quick. So let's do function with vals. Okay. We're going to create the new function, and it's going to be 5. Apparently we already had 5. Now it returns something, so we specify what it returns, and it returns an I32, and it just 5. Technically, without this, it should still work, but I guess they're trying to show you. I think it should still work. Let's see. We're gonna test that. So main is getting let x be the function of 5. Okay. And it is an actual I32, so everything is fine. Oh, maybe if we don't have that, it's not going to know how to do that anyway. And then just a simple print line just to see that everything is working. And I'm just going to skip, if you don't mind, I'm going to skip the whole typing a lot of stuff. No, we're gonna type. We're gonna make it nice. Well, 5 of x, I guess. Okay. So we get 5. Question is, if we remove the return specification and we put that instead, would that still work? No. Okay, so it is mandatory to specify a return value. Well, the return type. I wonder. Anyway, so we good on that. Everybody understand that? I understand that. Okay. Why though? Why do we have to return it like that? Function can return values to the code that calls them. We don't name return values, but we must declare their type after an arrow. Like, wait, what if we ignore that and just say return? Just return the 5. Why can we not do that? Expecting something else. Okay. So the return is can return early from a function by using the return keyword and specifying the value. but most function returns the last expression implicitly. Okay. Okay. I guess. I guess we could return that. We could use return in a loop or an if statement, do something like that. Okay. Um, this is just another example, but this one is an example where we pass in a val as a parameter. So instead of saying take 5, we're gonna say 5 will require in I32, just for the sake of it, and they both return. And what I does is takes x plus 5, I guess. And here we pass in the integer, the 5, and we're going to get a 10. Okay? Maybe I need to make that bigger, just to make it easier on the eyes. It's not like we're running a lot of code. Okay. Okay. Function main. What we're doing here, running this code. We'll print the values. X is 6, but what happens if we place a semicolon? Okay. This shouldn't change. I mean, it still is the last state. It does. Because now he's expecting something else to be here. He's expecting something like that. Like, this is still valid. This is a valid code. Because we're using a parameter, so he's not going to panic. He's only going to be angry about not using this expression, but it should run. Yeah. And he's not happy. He's telling us, hey, can you please can you clear that so we can see what we're doing? He says that everything he's just not happy, but it's the code is not bad. Well, it's bad. It's just not it's not going to panic. Okay, we know that, right? That it makes sense though, because Rust would always return the last line in a block as the, or in a function as the return value. So if the last line is not an I32, that's where he's going to be not happy, right? If we do something like that and we say, hey, let's return that, now he's going to also panic here because it's a different, it's not the right type. Even if we do that, he's not happy because he's going to say expected in I32, found it char. Right? But we can understand that. I mean, it makes sense why that would happen like that. Okay, next one. Comments. Do we even? No, we don't wanna. If you want comments, you control and then the forward slash would just make the line you're hovering on. In VS Code would just make that. If expression. Okay, if expressions. All right. Fun. I guess. Yeah. I guess we're doing that. Yeah. I I don't really like going back to the basics because but because I'm ADHD, but we're gonna have to do that, I guess. If expression express. Okay. Let's start with the main again, as always. You know what I like about this, about YouTube? I can stream and have nobody watching, and I'll be happy about that because all I want is to record that technically, and YouTube is letting me record that for free. Suckers. Because my computer has no more space. Because I record everything on my computer: gaming, playing, learning. Why I do that? Why do I do that? Not because some people might find it fun. No, because when I go back and watch it, I find it very nice. I find it interesting. Okay, so we have an expression, and the expression is number is 3. And now we want to do stuff with number, right? So we say if number, not num, he's going to do an import now, and we're going to climb all the way up and take num out because we're not going to be using that, and this one as well, we're not using that. If we want to use that later, we can call that back. I love this mouse. It's beautiful. It's very nice. All right. So expression of the expression is if the number is something, or if is a bool, I guess. I don't. It doesn't have to be a bool. We can do in range also. Well, which is also a bool. I guess if statement will return a bool. It has two options. It could be either true or false for each one of them. If you want to use, I guess if you want to use two, but like a lot of if you have a lot of ifs that you want to check, I guess you can just match, and we'll get to that later. Should be very soon, actually. Should be now, actually. Anyway, so if the number is smaller than 5, then print line, do something. And then we can say else, and print line. We don't have to always have the else, but it's good method to exhaust all method all options, I guess. Well, what would be the word for that? Okay, what we got? We got nothing. We're not printing anything. What? Why are we not printing anything? If the number is... We should be printing something. What am I missing? Oh, okay, now it works. It didn't work before. Okay, yeah, it works. All if expressions start with the keyword if followed by a condition. In this case, the condition checks whether or not the variable number has the value. Okay. We can say if number, right, is, and we can say between 0 and 5. Can we do that? Why can we not do that? Should be able. Why can we not do that? You know what? Actually, I'm wondering why can we not do that? Expected a bool found range. If number if number is equal to the, okay, we're just gonna put that in here. Will that work? Why do I... Okay, hold on 1 second. Can we... let X be a range of I32s. Can we do that? I mean, we should be able to do that. Or we can take this let statement and just inject that as a if let statement. There's a way of doing that. I don't remember how to do that, and now I'm gonna be bothered by that. So how do we check range? Well, maybe number not as a maybe unwrap that. Can we no, maybe we shouldn't do that. Oh, it's gonna bother me now, because I am pretty sure I have done something like that multiple times, and thinking, why can I not do that? Okay, so we need to create a boolean. Okay, this is where I'm working myself harder. So we need to create a boolean. And range for boolean. How do we range boolean? No, that's not what we want. Range in, yeah, should be. No, we don't have to. If oh, we're matching on that? Why do we match? Wait, if we had done that the other way, would that work? Without. Oh, okay, so it does work. Okay, so I'm just being, yeah. Do something, yeah, okay. Anyway, well, I'm gonna use the comments. Let's do that on top. Yes, because this is a new expression, I guess. It's the same as this, essentially, as this. So we have the if statement, right? So we have the variable or statement, and then we pass an expression. So the if is a statement, right? And then we're passing another expression in it. And that's why it's technically, I don't understand 100% why why the iflet is working that the way it is, but I'm sure they'll explain that very soon. Okay. We know it needs to be a boolean. Number is 3. If number is not 0, then print the line. That makes sense. Now we're doing a bunch of else ifs. I'm not going to do that. Use an if in a let statement. Okay, that's something that I would like to read. Okay, because if is an expression, we can use it. It's Yeah, but we can use it on the right side of a let statement to assign the outcome to a variable as a listing. Because if is an expression, okay, so if is an expression, it's not a statement. If is an expression, so we have expression to the expression. Then why won't this work without the let? I think we're missing a new a different I will be missing some information about that. Okay. There we go. Let us start with a function main, as always. Alright, we have a condition, so let I'm gonna stop it here. It's gonna be a boolean. Then let number. Okay, now we have an expression in this variable. So the variable is a number, and then we give it an expression, and the expression is if condition let's do it proper. What's your problem? What? Okay, oh, because we're not done. If condition, and then we're okay. So what we're saying right now is if condition is 5, then it will be will return a true, I'm assuming. And if condition is false, we'll return a 6. So it's not the value of number, so we're testing for the value of the condition. Right now, I don't understand why they wrote it this way. Because we're not getting the number, we're getting the results of the condition right now. And we get a 5 because that is true. But I don't know why they are saying the value of number. Because it's not the value of number, it's the number will be, well, I guess we can use condition as a switch for variables like that. We can use condition as a switch, and we can make it mutable and change it between true and false, depend on another part in the program. And okay, I guess remember that blocks of code evaluates to the last expression in them, and numbers by themselves are also expressions. In this case, the value of the whole if expression depends on which block of code is executed. This means the value that have the potential to be results from each arm of the if must be the same type. Yeah. Okay, that makes sense. Okay. We're not. Okay. So now we say if number. Oh, okay. We're testing what happens if um both in this instance, not in every instance, but or in every instance, blocks of code evaluates the value of the whole. I think it's every if statement. Well, it would make sense that every if statement. Both arms must return the same type. So if we, instead of this, we give it a, just for the fun of it, we'll get a, I want to get the error, so I can put that there. We'll get expected integer found a string slice. Okay. And now we're going to mark this one and unmark this one so we can continue in case we just need that. And of course we don't need that. All right, what are we doing now? So we know what's false because one of the branches, one of the arms was a string slice. Repetition with loops. Let's go for loops instead of. I thought in other languages they started me with usually they started me with for loops. If, for, and then loop. If, for, while, and then, well, I guess loop is something that I haven't seen much in previous languages. All right, let's go and do that. So start main, and we say loop, and that loop is going to just print a bunch of lines. I don't want to do that, but we know exactly what is going to happen. So should we do that? I'm gonna call that, because that is what's going to be happening. Alright, we're gonna play with that in a moment. Alright, and then just okay, I forgot. I just die. This is why I didn't want to do that. Now I need to open the terminal again. I don't like doing that because it opens in a very, very slow font, and I don't know how to change that. I mean, yes, I could check how to change that, and it would take me probably a second. But laziest will be laziest. We have 15 minutes. We have to do something. Okay, so we're going to. What do we have to? What else do we have today? Yes, we have a for loop. All right, we're gonna probably not get to the for loops, and the reason is because I want to play with the for loop now. So instead of doing this, oh, okay. That we're getting to that. So simple loop will run till we just run forever, I guess. Okay. And if we want to create a break, we'll have to give it, well, we're gonna have to start messing with that, right? He starts with the, okay, so we're creating a counter. Okay, I get it. So, and it has to be mutable. And the counter will start at 0. I mean, we can do that other ways. There are many ways to do that, but I want to learn the way we're supposed to do that. So results would be results would be a loop, and result will not run because the expression loop is not being called right now. So that's already good. So that ensures that right now, if we run the code, nothing will happen, nothing bad, at least. So counter is receiving an addition. We're adding 1. And then if counter, and then we have an expression inside the loop to test if something happens. So, and it will run every time, every iteration of the loop, this if statement will run, and it would check if counter is equal to 10. Right, so we're going to run, and then if it's not equal to 10, okay, that is interesting. I wouldn't do that like that, but this is why we're here. Counter times 2. Now, I want to understand before I execute, I want to understand exactly what happened here. Why are we doing this? Why are we doing this? To retry an operation, you know, might fail, such as checking whether a thread has completed its job. You might also need to pass the result of that operation. Okay. Before the loop, we declare the variable counter. Then we declare a variable named result. Alright, so result is just the, well, I guess, result takes ownership of the entire loop. But we're not in ownership yet, so it's we're not there. We don't know that yet. It adds 1, and then checks if the counter is equal to 10. When it is, we'll use the break keyword. Okay, I guess, okay, so what's going to happen is he's going to add 1 and come back here and check, and then he's like, no, that's not going to work, and he's just going to check again and again and again. And because every iteration of that is going to print something, right? So every time he's coming back to the start of the loop, he's going to print us something. So we're going to get a, okay, the countdown. Okay, so it is, excuse me, the result is 20. How many times did it take it to, how many times the counter had to tick before it got to 10? Why 20? Because it's times 2. Okay, so that's just to confuse us, I guess, because I was expecting a 10. That makes more sense. Well, I guess they're trying to show you that you can do math with that because it's still an integer. You can 932. You can do with that whatever the fuck you want. Okay. Can also return from inside the loop. Well, break only exits the current loop. Like we can also return something here, and instead of this being like that, do we want to do that? We can, yeah, we can just print and say now the count is, and then just give it a counter. I mean, that's theoretically that should work exactly the same. And it takes the results of 20 because, I mean, obviously. I mean, I think we can do that. No, if we want to do that, we have to take it out of the, we have to put it outside because we can't format the math operation. Everything within the the brackets, well, not brackets, everything between this is not it's not a code line, it's just a format for the code line. We have 9 minutes. Okay, we might be able to accomplish something today. All right, so now everything is going to be times 2. Okay, it's just it's not necessary. It's just for me because I like doing stuff like that. Like, it makes me feel smart. Okay. I was just saying that I like feeling smart. Disambiguating with loop labels. Okay. Now, excuse me 1 second while I check this. Remove certainty. Okay. Okay, so we're just parse or clean or whatever word we want to use for that. If you have loops within loops, break and continue apply to the innermost loop at that point. You can optionally specify. Okay, so if we have a loop within a loop, then the break and continue would only apply to, well, it makes sense, it's only to that scope. But I guess that's something you learn in ownership, probably. It shouldn't be something you learn the first thing you learn, because when you say the first lesson you learn in any programming language, right, is you create a function or you want to create a print, right? So when you do this, or whatever this is, I love this song, by the way. This is a very nice song. I love this song. Anyway, you don't know what song I'm talking about, but the first thing you learn in any language is, I guess, to what extent you have to what extent your powers apply, and your powers would apply here all the way from the start of the block to the end of the block. But the reason this block would run was because it is in the main block. I don't think that is a complicated subject. But then again, I'm autistic sometimes, so I don't know. Anyway, what we're doing now, we want to create a nested loop. Is that correct? Is that what we're doing? Yes, we're creating a nested loop. All right, let's create a count. Like a mute count. And it is going to be 0. So just so this is our switch. It doesn't have to be, but it's our switch. Having this before the, I don't remember what it was. The outer loop has a label. The label, it will kind of the specify label. Why would you not? Can you explain to me before we start writing stuff down? I want explanation on that. No, that's the Rust book. Why are you not explaining me? Okay, should improve that. I forgot why you have the is that a borrow? But it's not. We're not borrowing anything. In Rust. Let's see what we have. What we're looking? We're looking for this guy. It's a pointer. Okay, so that's a pointer. Named lifetime or loop label. Ha. That's not. This is why I don't like the AI. Label. What am I missing? What am I not? What am I not spelling right? It's just me. Shut the fuck up. Okay. It's a label. That's all it is. All right, so it's a label so we can break. Okay, I get it. I get it. Why? Yeah, it is a reference. Okay. Okay. So we're creating a reference for, and it's gonna be, the reference is counting up of type loop. Is it type loop, or is this just the label for loop, which is basically making loop the type of the label? Ownership is freaking amazing. I love this. I love this. I love this. Program languages have more logic than humans would ever have. Count is equal to count. So in this loop, we first say the print line. We say print me the count, whatever the count is. And then we have an expression. Let mute remain remaining with the double N. Yes, that's the double N. That's what hurts my eyes. Remaining would be 10, and then we probably subtract from that. Am I right about that? And then we create a nested loop within that, but this one we don't give it a reference because we're breaking, or I guess I don't know why. We could very easily give it a label, but we're just gonna go on with whatever the boss told us to do. We're gonna have another print line, because why not? We have 1 minute. We're gonna do an extended version today because I'm not gonna do 2 today. I'm just going to do 1 stream. 1 hour. Should do more than that, but I didn't plan on doing that anything today, but I just realized I scheduled something, so I was like, okay, fuck it, let's do it. So remaining, should we just do that? There you go. Happy. So happy. That makes me so happy. All right. So first we print a line, and then we say if remaining is 9, then we break. Now when we break here, we break from the inner loop. We're not breaking out of the outer loop. This loop will just keep running until we break it, or until it's no longer valid. Until if everything in it is going to come out as false, or everything in it is going to break, it should. The outer loop has the label. No, but let's just go back. Oh, we had it said here. It said here, and I was just being dumb. If you have loops within loops, break and continue apply to the innermost loop at that point. You can optionally specify a loop label on a loop that you can use within the break or continue. Okay, so the label is just so we can break from within the inner loop. Oh, so this is how this is our exit. So we say if remaining, and then we say if count, because that way we'll know when we get to our number. If count is equal to 2, then break the break what? Break the label of counting up, and then we say remaining. Okay, so this right now is not being executed. 1 second. We're just gonna finish with what we started. So we're going to subtract 1. We're going to subtract 1, and we're going to add 1 to remaining, to the count. Sorry, we're going to add 1 to the count, because that way, or this is going to be this way, this will actually count. Right? Now when we break, that's when we get, when count is equal to 2. So, all right, let's try to anticipate what will happen when we run this. Shouldn't be hard, but then okay. So first of all, we enter the we have the variable count, and it's 0, and then we start the loop by printing 0. Right? So first thing we do is first thing we do is we print 0. Okay? So count is equal to 0. And then this is just another variable. And we say 10. So it would print count 0, remaining 10. And then if remaining is 9, then break. But we're not going to break because remaining is 10. Okay? If count is 2, then break. So it's going to run through 2 iterations. It would loop once, so we're going to get the count 0, count 10, and then count 9, and count 1. Alright? Clear this. Alright, so we get count 0 is running once. But then again, why does it run again? Why does it run? Why is it running twice? Oh, because he's doing the loop. Oh, okay, because we're broke from this loop. We break from this loop. Right? We break the loop and we go back to the start. And then we come back down here. Yeah, because it's not 2. So the exit condition, the break condition is 2. So until we don't meet the 2, he would just try this, fail, then we would try this, succeed, and he will break. But if he tries this and he fails, only then he will continue. So this is only executed if this fails. Okay. Well, yes, this will be the end for today. I'm just gonna be smart about that today, and just gonna copy that and put that where we left off. Because otherwise I will not remember that for the next time. Alright, so next time we're going to be streamlining conditional loops with while. This should be actually fun, and this should be the start of me losing my sanity, because everything from here on out is a downhill. Okay, well, bye.